Hi everyone, welcome back to the Big Data Analytics and Data Science Interest Group. As promised last time, today we'll be talking about the data analytics lifecycle and the methods that are involved in the process. A question you might already be having is that what is this data analytics lifecycle and why does it deserve a dedicated video? The short and simple answer is it's easier to work in a structured environment when you have a lot of unknowns rather than to get lost in that environment. I'm sure most of us can actually relate to at least one of these pictures, if not all of them. And if you happen to not relate to any of the pictures, then chances are you might be the computer in the first picture. We've already discussed that most of the data that you'll encounter in your big data project is unstructured data. And as we spoke about it last time, unstructured data basically requires a lot of processing to actually get into a form that you'll find it easy to put it into whatever framework you'll be working in. Now, a common joke in the big data scene is that data scientists are mainly data cleaners more than anything else. And that should serve you as a clue, that should serve as a clue as to where most of this data science time actually tends to happen. The way we've been working mostly thus far is that it's an answer for an answer type of setup. So I have a couple of questions that I would like you guys to consider, and after that, I'll give you my solutions. The first question I'll pose to you guys is, how do you currently approach your analytics problems? And by analytics, I mean, how do you systematically approach your computational analysis of data or statistics? Do you follow a methodology or some kind of framework? And how do you plan for your analytic project? As always, feel free to pause the video and engage these questions at a level that sparks your interest. Just to clarify some matters, just in case you might be lost or you're not certain as to what I'm talking about, let's go through a simple example that will try to help you go through these questions in pretty much, okay, it's not as much of a real time, but in whatever time you'll take. Some people might feel that you can't do any computational analysis without a computer. Well, I'm on the side that says you just happen to have one of the most computationally savvy tools inside your skull. So let's actually do some computations using it. Now, if I were to come and give you statement A, which says, all great men are ridiculous, and someone from the interest groups replies and says, well, I'm ridiculous, with the inference that they are a great man, and I ask you, how would you critique this whole scenario? What options would you choose? Would you choose option A, which says that statement is true, option B, which says that statement is false, or option C, which says that statement is not clear? Think about your solution, and after or whilst you are thinking about your analysis, do ask yourselves the previous questions which are in this context. How are you currently approaching this analytics problem? Do you follow a methodology or certain framework in answering your problem? And how did you plan to answer this problem? Do feel free to mail me your attempts, and I will discuss this simple problem with you then. The whole point behind that riddle is quite simple. It is to test how do you respond to a situation where you're given a problem but without any explicit data. And if you think about it on a deeper level, that's what data science is really about. As I mentioned earlier on, the whole point behind a structured approach to data science is, in most cases, whenever you encounter a new problem, it might seem at first as a huge problem and daunting. But as soon as you have a well-defined process that enables you to break that big problem into smaller pieces that you can address, everything seems to go a bit easier. And in most cases, what you will find is that as you are addressing those small problems, they'll either give you hints as to which direction to go, or in some cases, they'll also reveal how flawed your initial thinking was and force you to go back to the drawing board to try and draw up simple problems that you can solve and begin building on those solutions. Thus, having a good process for performing analytics is critical. It will ensure that you establish a comprehensive and repeatable method that you can use for analysis, and this will in turn allow you to communicate your work more efficiently whilst highlighting the need for documentation. You'll also have the benefit of collaborating with larger teams and most importantly, you can get critique within the context of the phase that you're actually working in. Last thing to emphasize is there's a lot of challenges that you'll face whenever you're dealing with your big data projects. And having not to worry about the methodology that's being used goes a long way in ensuring that you'll be spending more time doing the critical work rather than thinking about what methods to use to solve your project. You might begin to ask yourselves, what are these phases? Well, I'm glad you asked. There are about roughly 6 phases involved in the data analytics lifecycle, and work on these phases can happen concurrently, depending on the size of the team and project you're working on, of course. With the movement between the phases not unidirectional, and in most cases you'll need to bounce back between adjacent phases based on the challenges involved in the phase that you are currently in. Something I should note is, even though the title says Research Data Life Cycle, you'll soon discover that if you happen to go into industry, the title will change, but the underlying principle stays pretty much the same. The choice is useful for us, and similarly, theirs serves their purpose, whereas the science remains indifferent. Okay. The first phase is the planning and design phase, which can be summed up as the discovery phase. In this phase, you need to learn the domain you're working in for your project. This includes the relevant history behind the project, things such as literature, looking at whether it has been done before. You also have to assess the resources you'll have to support the project in terms of the people, technology, time, and data. And the most important aspect to consider here is how to frame the problem as an analytic challenge that can be addressed in subsequent phases. And the way you go about doing that is to formulate the initial hypothesis that you want to test and begin to learn the data that you'll be using. The last portion is of paramount importance because you need to know what you're looking for before you start drawing up fancy models. That ensures that you do not shoot in the dark in a massive vacuum, and as we've noted time and time again, if you don't know what you're testing for, then doing data science using big data will be a nightmare. As you might note, this is around the time where the project is being announced and you are in need of a starting point. Moving on to the next phase, which is the collection and data capture phase. In this phase, you are mainly involved in data preparation. So now you're preparing that analytical sandbox we spoke of last time, in which you can work for the duration of the project. This involves cleaning the data and beginning to transform it into data structures that allow you to have ease of access and analysis. Thus, you need to familiarize yourself with the data thoroughly and take steps to condition that data. The third phase is the collaborate and analyze phase. In this phase, you do your model planning. You determine the methods used, what techniques are needed, and the workflow you intend to follow for the model decision making. Now, you explore the data deeply to learn about the relationships between the involved variables. Analysis, you would then be able to select the key variables that best describe what you want to do and the models that you are likely to use. Phase 4 is about model building. You now should be at a stage where you are developing data sets for testing, training, and production purposes. That also involves how to manage, store, and preserve your data. You then get the best environment you can for executing models and workflows, including fast hardware and parallel processing. Once you have that environment set up correctly and your models working in an optimal way, you are now in a phase where you can communicate your results. You then can determine if you've succeeded or failed based on the criteria you developed in the discovery phase in collaboration with your team or supervisor, that is. You then identify your findings, quantify their importance, and voila, you can then develop a narrative to summarize your findings, convey them to the team and the scientists involved at large through publications and other information sharing channels. In the final phase, you would now be confident that things work as expected. In reality, it's close to the expected result, not exactly, and you can begin to operationalize your work. This involves delivering the final reports, briefings, codes, and technical documents. From that, you would then be able to run a pilot project and implement your models in a production environment. I reiterate once more, that once you've actually produced your results and you're certain that your models work as expected, it is important that you frame those results in a manner that is appropriate for the audience that first gave you the project to work on. Because what tends to happen is that you have a lot of people who are good in data science, but they don't know how to present those results. The negative to that is that if the person or the team or supervisor that gave you the work cannot see the clear value of your project, it's very unlikely that project will be used, and we don't want to waste a lot of the time that you'll be putting in and the resources that you'll be putting in whichever way. Thus, now is the time to get into the groove of practicing this very important skill that you'll be needing for the rest of your life. In summation, after going through this video, which was all about the data analytics lifecycle, you should be able to, one, explain what the data analytics lifecycle is about, talk about the attributes involved in each phase of the data analytics lifecycle, and you should be able to identify where you are in your project in that lifecycle. After such a pleasant and short video, in the upcoming videos we'll begin to get technical, as most sciences do, and your journey into being exposed to data science will be well underway. We will be introducing some of the key basic concepts that you'll be using in your projects. And yeah, see you next time. Cheers.